All right, so in order to model this relationship, we are going to have to use an error correction model, which is a multivariate time series model used for data that has a long run stochastic trend. So keep in mind that log Bitcoin prices is non-stationary, and alone, maybe log differences could have some predictability, but if you're just looking at log of Bitcoin prices alone, you would not be able to develop a model for that. And the same goes for log stock to flow, or the log stock to flow ratio. So that is also a non-stationary time series. However, even though both of these are non-stationary, the difference between the two is, which means that they are co-integrated. So one influences the other. So a log stock to flow ratio could potentially influence, or as we've really already seen, that the log stock to flow ratio influences the log Bitcoin price. So even though the both of these are non-stationary, you could use one of the two to estimate the other. So in order to do this, we're going to use an error correction model, which is also able to estimate the speed at which they'll go. So there's a log run equilibrium. There's a log run stochastic trend between these two. And even though they're both random walks, they're going to move together. So to do this, we're going to use a vector error correction model. So this is in chapter 10 of the slide. So in chapter 10, we'll talk about, or there are notes on the vector error correction model. And what this does, here's the formula. So xt is log stock to flow ratio, and yt is log Bitcoin price. And this is all daily values. So here we have a constant, and then we're going to look at the difference between the two. And we're going to look at lagged values for X, which is log stock to flow. We're going to look at lagged values for log Bitcoin prices. And then in the same, we have a similar. So the coefficients for these, they're different. So for the log stock to flow ratio, all of the coefficients that we're estimating are different than the coefficients that we estimate for the log Bitcoin price. So anyway, to do this, we're going to create a blank data frame. So var equal pd dot data frame. So it's just a blank data frame. And then we're creating a column X. X is the log stock to flow ratio. Then we're creating a new column Y. And Y is our log closing price. And I'm setting the index. So var.index is equal to our timestamp column. Now after this, I'll do head, look at the first, let's look at the first three rows, and we see it here. So time step is the index, and we have October 14th, 2010 onward, and this is daily values. Another thing to notice, here we have y is negative, and if we plot it here, this is of course the same graph that we already did, but y is negative. Y is log Bitcoin price, and of course price is non-negative. Price is, or would assume to be non-negative, but it's log Bitcoin price. So keep in mind, log can give out all real numbers, but the input for a log has to be positive. You cannot take the log of a negative number. But that would mean that it's less than 1. So this would be very low prices. May not be best, but here, so here, then on, you can see that it's positive. So I mean that the prices are getting larger. But even though log is negative, the price itself would still be positive, because you cannot take the log of a negative number. Just something to keep in mind. So here's the plot. So we're saying that both of these are non-stationary. So the log Bitcoin price is non-stationary. The log stock to flow ratio, X, is also non-stationary. But the difference between the two is they move together. So one of these moves the other. So in order to estimate our VECM, or vector error correction model, we're going to import stats models .tsa, time series analysis. And in this, we're going to import vector, vector AR, autoregressive. So we're going to run this, import. So now we've imported vector AR. And on this, if we type in vector underscore AR, and we press tab, you can see all of the different packages or functions that you can use from that. So we're going to do a VECM model. We're going to do a vector error auto correction error correction model, and here's just VAR, which would be a vector autoregressive model. But anyway, so we're going to create our model. So MDL for model is going to be equal to vector underscore AR dot VECM. Then within VECM, so if I do vector underscore AR dot VECM, we have still, we have other functions that we could do. You could do test for co-integration, which is what we did. The test for co-integration that we did earlier, this is the Ingle-Granger test, but there's other tests for co-integration. And if you read some of the papers on the scarcity model, they go into some of the other tests. But for now, mainly we just did the Ingle-Granger test because it's a little bit simpler. You just look at the residuals of the regression, test for stationarity, and that's all there is to it. For the others, it's a little bit more complicated. Not too much complicated, not too much more complicated, but it is a little bit more complicated. But anyway, so we create our VECM model, and then we set the endogenous variable to be var, and this has to be both. It has to be both X and Y. It has to be both log stock to flow ratio and log Bitcoin price. If we just plug in one, let's say Y, which would be the price of Bitcoin, and we run this, you're going to get an error. So only gave one variable to VECM. We don't want to only give one variable. We want to give both because it measures the difference between the two. Then for K, AR difference, this is the number of lags. The default, if I press Shift Tab, we can go down here and we can see K underscore AR underscore diff. So KR diff equal 1. This is the default. So for this parameter, you have to give it 1. It's the number of lag differences in the model. The default is 1, so we'll set it to 1. And then here we have the deterministic. So this is the deterministic trend. If I go over here, press down, I'll go down to deterministic here. So you have these options. You have to give it a string. So string NC, no deterministic terms, CO, constant outside the co-integration relation, CI, constant within the co-integration relation, which would be based on the difference. Then you have a linear trend outside, linear trend within, and so on. So you have 5 different options. So after you specify that, you're going to fit, and we'll print out the model summary. So here, this is with 1 lag, and these are the coefficients or the estimates for the coefficients in this model. So with this, we're only saying 1 lag. So we're saying that this would be equal to a constant. So XT, log stock to flow ratio, is equal to a constant, which is, these are the lags. You see error corrections. This is the difference between the two, and then beta 1, beta 2. So this, it would be the constant plus our error correction. So it's the difference between, well, yesterday's log stock to flow minus yesterday's log Bitcoin plus some coefficient. Here we have, it's right here. So for X, loading coefficients alpha for X1. So negative 0.0151 multiplied by the difference between these two, plus then some parameter or estimate multiplied by yesterday's log stock to flow ratio, plus some coefficient multiplied by yesterday's log of Bitcoin. Then you have your error. And then same thing for Y for the log of Bitcoin. It's just reversed. And these coefficients are not the same. So here we have A, so for log stock to flow ratio, we have AI multiplied by some, or whatever last lag or some lag of log stock to flow ratio. Here we have C1. So A1 and C1 are not the same thing. B1 and D1 or BI and DI are not the same thing. Here we have gamma X and gamma Y. So these are not the same gammas. Here we have alpha X and alpha Y. These are not the same alphas. So anyway, here we have our VECM model. So we fit it and we print it off the summary. So this is what you would attach. So even though both log Bitcoin and log stock to flow are non-stationary, the residuals are stationary. So we are able to estimate one or the other due to co-integration. So next video, we will go over actually plotting this out and using it for the potential predictability.